and just going through massive amounts of literature trying to look at all the studies that have done some sort of analysis of how much fish you eat and any kind of health outcome that is relevant for the human population. There's a huge amount of literature that we need to sift through. And of course, we should do it according to various protocols and follow guidelines uh, and do this properly. So it's very time consuming. So this is just some basic stats where they've looked at this and say that well-trained staff can screen using the abstract in about, well, two papers a minute. And then it's not really, it's not exactly what we want, but it's the first step, right? So it's sifting through the literature into piles of stuff we don't want to look at more and stuff we need to look at more carefully. So in general terms, one working day would be, if you do two a minute or one a minute, it will be about 500 abstracts. But for 1,000 abstracts, if you're perhaps well trained. So in just one of the many searches we did in the fish project, we had several, I think we have 25,000 hits that needed to be screened. And this is a lot of time that is spent. So of course, there are many people who have thought about how we could automate this. And we started thinking about what are the, in the most general terms, this was not really necessarily our field. We started thinking, so what is the relevant information that we look for in papers when we screen them? Of course, very often you have people looking at stuff from their respective fields, or at least in VKM, we have experts, external experts that are part of our projects, and they are working scientists and researchers, and they know their field. They know which journals are more likely to produce relevant stuff. They also, of course, like look at the years, authors, and the type of articles. And these are things that information about the paper that pops out very often or very quickly that you can evaluate with some experience. And this is, of course, the text itself in both the title and in the abstract is something that we look at as screeners, but also something that you could automate in a way. And all of these things are sources of information that you could, at least in principle, derive or extract using some sort of automated methodology. We started thinking also about there are some people who have tried to see if you can identify relevant tables, or there are some approaches where you can, that are primarily used to extract actual data from papers to be used in a meta-analysis that can, if it's a PDF that is coded in a particular way that most journals do now, you can identify tables and what would be statistical analysis or statistical information in papers. Same you can also probably do for, or you could do for figures. You can extract figures relatively easily from papers automatically. And if you're lucky, there might be some information you can automatically extract from there. For instance, legends or labels on the axes that would give you some indication of what kind of information would be in there. We started thinking more and more about, or I started thinking about the idea of looking at the citation network. So essentially, the the combination of either papers who cite other papers and who are themselves cited by other papers, or author networks, like authors that usually cite other authors or even institutions. And the stuff I'm going to put out here is based on this. And a lot of the ideas in the current project that we're trying to do grew out of these preliminary ideas. So this is just how I imagine these citation networks to be built up. It's a relatively difficult process to build them up ourselves. And I see now that Microsoft is obviously doing that to a certain degree for us. And that's good because it's hard. So ideally, any sort of network like this should contain all sources. So we do, at least in my head, we start with some search. We start with a proper librarian-assisted search to get at what we think might be relevant literature. And before we actually go look at that literature, we also extract all the references in all these papers, and also all papers that are citing the initial searches. So there are this of course immensely increases the amount of information in that search. You end up with what I've denoted here as a primary library. This is essentially what your prelim or your first search gives you, and then you extend that to be the primary library and all the references in there. And you can also do that the other way around. So you sort of build up your library to include all possible papers that cite the papers in your first search. So this would then be sort of the expanded universe of what could potentially be relevant for the question at hand. There are different kinds of networks that we can build from all these individual articles. Like I said, all the nodes, or like the dots that are connected by lines or by vertices. These could be articles, these individual articles, they could be authors, or they could be institutions. They could probably also be a lot of other things, but initially we thought about these three. It could also be linked through co-occurrences. So who are collaborating usually with others? So what papers share more authors than others? You could also do it by common keywords and try to link all the different papers together in the degree to which they share keywords or have same kind of words used in the abstract or something like that. So this is now I don't even remember. This was one of the examples that we tried out 3 years ago, I think, where we took one of the initial searches for one of the projects at VKM. And back then it was hard to build this extended library, mostly because you could readily find. Let me think about this. How was this again? It was hard to get both. You could do citation search, so you can do it paper by paper in your primary library and get all the papers that cite them. But the other way around was was hard. Also because it wasn't necessary, at least for the older parts of the literature, it's not really even digitized, right? These are just digitized old published papers where you don't really know, you cannot extract the information on the references in each of the papers. So this is just a quantitative one example of a coupling network from, I don't even remember how many papers there were, 500, 1500, something like that. And all the links between them. So one node here is an individual paper, and if there's a link, they share a reference. And you see that there's some denser parts of this network, and there's some more sparsely populated parts of this network. And the idea was that we build this network up so we could perhaps train a classifier on it. So this is a co-citation network. I'm not going to go too much into the details of these different kinds of network, but it's fairly obvious that you can imagine many different kinds of citation networks based on how exactly you create the links between the papers. So what you can do when you have these networks is that you can do some basic approaches to any kind of network you have. You can look at which nodes are most linked to other parts of the network, like key nodes or centrality. These would be, if the nodes are papers, these would be papers from the whole collection that are deemed that have some sort of central information in them because it links to a bigger portion of the network than others. This could also be a way, if you do the nodes by authors and the links by how many times they've published together or cited each other for that matter, you could also get reasonably accurate information on who are the key players in the field, like who are the researchers that you should look more carefully after the papers they've published, or institutions for that matter. You could also do this to rank the articles. So very often when you see this Prisma flow charts, you go from a search and you go to screening, and it doesn't really say anything specifically about how you order the paper or how you screen, in what order you screen the literature. Usually in most of the applications that can help you do this, they do it randomly, or in some cases they actually do it alphabetically, which is one of the reasons why in some applications, or in some meta-analytical reviews at least, there's a higher percentage of papers included that are that have authors that have letters that are in the beginning of the alphabet. And these are artifacts of the order at which you screen, because you begin very carefully and then at the end of the day you sift through more quickly, and like there are a lot of these human biases that occur when you go through the screening process. So ideally the order at which you screen should perhaps be randomized from the primary library when you try to include or exclude papers. But by using a simple usage of a network like this could be a way to rank them in a way that you start screening what the papers that the network deems to be more central for the study at hand, right, or for the question at hand, and that could perhaps make you or you could, at least in principle, imagine some sort of stopping rule that in the beginning you're more likely to find relevant papers, and the further you go through your stack of a gazillion papers to screen, you're more likely to find papers that are irrelevant. And a stopping rule could be, if you haven't found a relevant paper in the last 100 ones, you can stop. Or it could be like rules of thumb that could at least prioritize the effort that we use in the screening. Another way you could do this is to try to remove the bias of the central or the centrality of such a network. So in some cases, you might end up by screening or including literature that doesn't really span the what do I call it, the whole network. So ideally, for a given question, you shouldn't just find the papers that are, you should find the papers that are relevant, but there is an inherent bias in the scientific literature, and trying to avoid that bias is something that you could do by identifying and trying to spend or to sort of upgrade papers that are less connected in the network. They might be less connected because they share fewer authors, and therefore they sort of have perhaps a more independent perspective, you could argue. And there are many ways in which you can use the information in the network just to affect the order of the manual screening itself. You could, of course, also, as has been presented earlier today, you can use this in sort of supervised learning. So you have a massive library, you screen some portion of it, and you use the information in the citation network of the ones that are relevant versus the ones that are irrelevant to train a classifier, essentially. So this is a very simplistic way of showing the basic idea that you have a primary library, you screen manually some of them are included, some are out, and you've left some sort of portion of this big library unscreened, just as presented earlier today. And while using text mining and natural language processing, you would probably look at the frequency distribution or some sort of aspects of the actual text in the abstract or the full text of the manually screened ones to train a classifier that you apply to the unscreened ones. In a citation network, which I guess is to a large degree something that happens in this Microsoft academic graph, the application of a trained classifier on the unscreened portion would be some sort of weight system or some sort of support vector machine, I don't know, some sort of learning algorithm that would give weight to the unscreened papers and whether or not you should include them or not. And these are, I'm not going to go through all of this, but there are a couple of points in this process where you can stop it depending on how much you want to automate, right? So just as I said, you could use the network raw to rank papers in order of sort of externally deemed relevance, and you sort them and you go through and screen them in the order at which they are preliminary ranked. That might save you time because you're more likely to actually come across the relevant papers in the earlier parts of the screening. And for some, you could, in the beginning phase or in some trial phase, try to identify a cutoff point at where you should stop looking for more papers because you deem the rest to be irrelevant because they have been ranked by this system. Yeah, there are of course different ways you could improve the system and include more than just the citation network itself, and I guess that's one of the parts of this project. You could, let's see here. You could also, and this is perhaps similar to what was just described in the Microsoft academic Graphity talk just before mine, was the idea we got that you could use these citation networks to for the identification phase. So essentially you do include in this network a larger library than the initial librarian search would give you. And this would be a way to actually make sure that you capture all the relevant literature. And it could even improve the initial search or the search of the whole literature compared to the more traditional way of doing it. Yes, that was me trying to give a talk I gave 2 years ago to you, and hopefully it was somewhat informative. Thank you.
Thank you very much, Jostein. I still find it quite inspiring after all that time, and still finding difficult occasionally to actually understand what's going on there, but I'm sure you do understand. One thing that strikes me is a potential use for, let's say, some kind of searches that would not include structured studies. And in that case, what is your gut feeling with those ideas that you had? If one could identify, let's say, relevant review articles, a certain number of review articles published lately, and start the search through the citation network that way, how would that reflect on the sensitivity and specificity?
Oh, I have no idea how it would affect the classifier itself, but surely that is a way to increase or to sort of gather more of the relevant literature in the in the first part of getting the bulk ready before you do screening. And this is like snowballing, they call it usually, is very often performed after the initial screening, and then you look at what are these are the relevant papers. Are there review papers that cite these that we have missed? And there's a lot of that's very commonly used in manual parts of refining the library you end up with after screening. And of course, in principle, you can do that in a citation network. If you have a massive citation network, and Microsoft obviously has one, you could at least in principle sift through all those links and get most of the relevant papers. But you of course you would also get a lot of irrelevant ones then. And very often, like the simplest part of screening is finding things that are completely irrelevant. But if you only look at stuff that are references in relevant reviews, very often you will probably get papers that is harder to identify as irrelevant because they are closer to what you're looking for, but they're not exactly what you're looking for. So it's hard to say how that would impact the classifiers, but it will probably not make them worse. It will probably improve them, I would say. That's my gut feeling.
Okay, thank you. That's what I was hoping for. Any other questions for Jostein? Radoslav.
Yes, I have a question and a comment. The first question concerns, as you call it, use supervision in this approach. When do you stop manual screening, when you put supervisor in the process?
Well, if you have to go through 22,000 papers, then going through half would save you a lot of time. I guess that's the main point. And so these are initial ideas, and these are my personal feeling is that a lot of these automated processes are they don't do the job as good as we would hope for the screening part itself. But the better they do a better job, the better trained the systems are, at least for classifiers. But I don't really, I don't think we would be able to use an unsupervised algorithm to screen the literature. I think I'm not entirely sure how that would work. Yeah.
I think there are some attempts to do that. Some people try to put some criteria to stop calibrating classify, and then to use this classifier for automated screening. But if you look at this citation network, and if you put supervision there, I just wonder whether you could put some criteria there in the process to stop manual screening at some point.
Sure. In principle, you can put in whatever you want, I guess. It wasn't really something that we thought a lot about. A lot of the ideas here came from this EFSA project that Danica mentioned in the beginning, where they tried to do this using text mined abstracts for big databases, and it works to a certain degree, but not that well. And this is where we started thinking about, so what other kinds of information would be easy to formalize, and that's where the citations, that's where the idea grew out of.
Okay, but of course, because as far as I follow you rank papers, articles, yeah, you want to screen. And then the simplest criteria is to stop manual screening if you have screened, for example, half of all these papers. I guess this is the only criteria probably you can use there.
Sure. Yeah. Yeah.
Okay. So my comment, because this approach has been extended by putting some semantic information.
Absolutely.
So they try to do that. Some people try to do semantic network. So they annotate the papers based on the ontologies, and then they introduce some measure of similarity between papers, and on the basis of this similarity, they generate a graph, a similar graph as you have in citation networks.
Yes, that's true. So ontologies are really hard to make. I've been trying for quite some time in parts of ecology to make ontologies. For some parts of the medicinal literature, it's probably easier because they have a more formalized way, or the types of studies, they fit more in a formal way. But you're absolutely right. Like, these networks could be made of anything. They could be semantic networks. They could be based on ontologies. So in principle, they could be that. But I guess what the original idea was that there is so much information in the citations themselves. So these are individual researchers that have spent their career knowing what is relevant, what are good papers, what are bad papers, and just I know that there's a bias in the citation structure of the scientific literature. Of course there is, but papers that are highly relevant are cited more because they are deemed by a lot of individual scientists as more relevant. So this we're sort of tapping into the individual evaluations of all the scientists in the field by looking at the scientific or the citation network.
Okay, thank you.
Thank you. Any other questions for Jostein? Radoslav, your hand is still up.
I have
right,
a question.
Anis.
Hi, Jostein. Yeah, very nice presentation. Yes, yeah. In fact, I have seen some of your slides. When we were writing the draft, and it was very inspiring. So at least our work package is very much based on the ideas that you have presented. So one thing that I would like to understand. So so we have the citation network that is a kind of let's say maybe we can look at it as similarity measure or a ranking measure. But what I did not really get is that when it comes to the supervised learning part, the classifier, do you use the citation network as a type of feature, kind of? I did not really get that part.
Good question. Let me think. I guess yes. I guess what you would end up with, or one way to structure the data of this network would be a massive matrix with sort of a link with each paper being a row, each paper also being a column, and you have an indicator on whether or not this paper cites that one or is cited by that one. So you could use that sort of matrix. If you use it, yeah. So it would be big, but that would be one way to sort of actually code the network itself. Ideally, we would be able to do, or ideally, I don't know. One idea could be that there are some of these networks could have direction, right? So if you have individual articles, you can of course link to papers, but it doesn't necessarily say something about who cites who, right? So all citations not only have a connection, they also have a direction. And this is information that is sort of more than just any semantic network that would link things that are similar. This also has a direction that could be informative.
Yes, and if we think about supervised learning, then what will be then humans needs to be in the loop to give some input, isn't it? So what kind of input that will help the machine learning that we humans are can give us? Can we, for example, label? Is there some idea like this? For example, what Radoslaw spoke about, for example, active learning, it means he will put the user in the loop to rank some of the, to label some of the data. So it here, what can be the role of the user in the labeling process?
Well, I guess we could rank relevance in more than yes/no categories, right?
Yes.
You could, when you go through literature and you go through these screening processes, very often you can identify papers reasonably quickly that you know are central. Like these are, you know, they include this big study. You know that this is it's a classic study. It's done by all these gazillion authors. It's in that journal. Like you can perhaps identify sort of key nodes in the network, but when you do the manual screening, that would be more than just include, exclude. That could be one way.
Because of course the user will start with some seed articles, like these are the 2 or 3 main articles that are very interesting. Please find for me more articles. Do you think that the process in this process of starting from a seed articles and extending this set with more relevant articles, do you think it makes sense to have the user in the loop, because the system will present to because this is at least what Rados also probably is also thinking about in the same direct, because the system will recommend maybe top 3 most important articles, and then the user can give feedback, and then the system will refine again the search. At least, do you think this can be a kind of, is it aligned with your ideas, at least from VKM?
Sure, in principle, yes. I personally, I think that more human interaction is better, but and ideally we would just have people to do all this work, but but that world we're not in. So it's striking that balance right on what to automate and where does the human manual work actually come in parts of the workflow here. I think it's these are very good and important questions to think about.
Yes, very good. Yeah, because in fact, basically, this is what Google is doing. It's when we interact with web pages, it learns at least a little bit our preferences, and the way the Google ranks web pages is personalized. What you get as ranking when you do the same things is different from what I get. So yeah.
May I add something to the discussion? You can do the following. You start with some seed papers, which are screened manually by experts. And then you take all other papers, which are not already labeled, and took all these papers, which are the most similar to this labeled paper and ask expert to rank them with the most similar to labeled papers. So you will have a look then. But the problem is when to stop this process. Thank you.
Excellent. I'm looking for any more hands. And it doesn't look like there are any more. Radoslav, you have the hand up. Is that a new question or just the old hand? I suppose it's the old hand, Radoslav, as you're not entering into the conversation. Thank you very much, Jostein. This was very informative, and now I think we could go further back to our agenda. And now it's the Norwegian part of the project, which is a work package 3, which Anis is going to present, and that is the work package on the citation network tool and what kind of input we need in there. The other part is the work package 6, as it was mentioned before lunch, and that is the part that is going to be undertaken at the very end of the project, where we are going to use the tools parallel with the ongoing literature searches conducted in the traditional way. Compare the outputs of those searches in terms of sensitivity and specificity, and in terms of use of time and human resources for conducting those different searches. So we are going to summarize the findings and write the recommendations for the future use. And now I would like to invite Anis to present the work package on the citation networks. Please, Anis.
Yes, thank you, Danica. So I will share now my presentation.
Yes, we can see it now.
Excellent. Okay, so I will speak about this work package. So I chose a few keywords, at least that are important for this work package. It might be, so this is in fact a discussion, more as a discussion than rather as real research, because at least from our side, we did not really start the project because of some delays with hiring the postdoc, but I think those issues will be soon fixed. So so similarity measures is maybe the topic that around which revolves at least this work package will be based on citation networks and embeddings and of graphs and words, and I will explain what those words mean. So so sorry, this is the last slide. So what are the tasks in this work package? So the first task would be first to conduct a literature review around the state of the art related to this topic, and then a development of tool for information extraction based on seed articles. And not only seed articles, but criteria for systematic review, such as keywords and inclusion and exclusion criteria, and development of literature ranking tool based on citation. And the last part will be the testing of the tool, not only in terms of sensitivity and specificity, but also user evaluation and feedback of the tool. So now I will go to the plan for this presentation. I will explain a little bit what is co-citation and co-coupling. It was very nicely covered by Jostein. I will use some of the slides of Jostein because why I found it so interesting, because I found out that some of the things that Jostein has been speaking about related to one famous algorithm called HITS, that is based on the idea of co-citation and coupling. And then I will speak a little bit about some promising novel techniques for similarity when it comes to text analysis, and also when it comes to citation networks. So I will start with the simplest, one of the simplest and most famous algorithms in internet is called PageRank. It was developed by Google in the early stages of the internet, and what PageRank algorithm does is to give an importance or a rank to the different web pages according to some graph theoretical measures. And the idea of PageRank is so simple. So so if we have different web pages, or you can think about it, or different even articles that are linking to each other through citations. So a web page that is for which there are a lot of incoming links gets higher ranking, and a web page that has a lot of outgoing links get lower ranking. And the idea is simple. For example, if we take CNN.com, so you'll find a lot of websites that are pointed to CNN, so it means it has high ranking. And if you get a blog that is not important, that is pointing out towards many other blogs, then it loses its ranking because it has a lot of outgoing connections. So now I took 3 slides, in fact, from Jostein, despite he went through them, but I found those slides so interesting because it has been inspiring and motivating when we wrote the application, and even in the process of planning this work package. So Jostein spoke a lot about co-citation networks, and also he spoke about trying also to build some kind of networks based on authors who have collaborated together, and also based on keywords. So in a way to find ways to link articles, not only based on citations, but based on maybe authors that have collaborated together. So so it might be or based on common keywords. So so what is co-citation? So simply if 2 articles cite A and J, both cite K, then they might be related in some sense. So this is this is some known stuff. So usually when we speak about co-citation network, we speak about this citation matrix, which is n by n matrix, where n is the number of articles, and you have Lij is entry is 1 of 0 on that matrix. Lij is equal 1 if paper I cites j. And so the co-citation can be computed using simple algebra, and this is called so this is based on this L matrix that we call the citation matrix. So it's a very simple algebra. So and there is this bibliographic coupling. It's 2 papers are coupled by bibliography if they cite the same articles. So here I and J cite the same article K, so they might be related in some sense. So and this is a formula for finding this coupling based on this citation matrix. So we can find the bibliographic coupling. And and why I found this interesting, because when I looked at the slide of Jostein, he spoke about coupling as a measure of importance, like in a way that or the similarity, at least the number of shared references between 2 articles is a measure of their similarity. Co-citation is also another measure of similarity between articles, because yeah, it's the number of third articles citing both of them. So this interestingly relates this. There is an algorithm called HITS that is as popular, maybe not really as popular as PageRank, but is very popular. That has that came in the same year as the PageRank in 1999. And it's called hypertext induced topic search. And this algorithm uses exactly the idea of co-citations and co-coupling. So what this method does, it tries to rank web pages, but in fact it is more suited for ranking research articles. It's really suited for ranking research articles. It has two notions, one notion of authority and one notion of hub. An authority is a page, you can see an article with many links. So it's an article that is highly cited. A hub is a page with many outlinks. So this is the figure. So you have an authority, it means an article maybe that is an authority in the field, so it's highly cited. A hub is an article that cites a lot. So this is the idea is so simple. So and there is this algorithm that runs iteratively. You take web page X and you find the number of articles that for a hub you find the number of articles that are citing that are cited by that web X, and you go to those articles and you find the number of articles that those articles cite again, and so it's iterative process. And for the authority, it's the other way around. We find the number of links, but we repeat the process so many times. So if we repeat this process so many times, we get two measures. One is the hub. It's a measure for how, if we do this process iteratively in a network, so we get two measures. One is so-called the measure of hub, which is based intuitively on the co-citation matrix. So now we are going back to co-citation matrix. A good hub points to many good authorities. So this is the idea. Is like the number that we get. So we get two numbers. One, whether this paper is a good hub, means it points to many good authorities, and then we can use the co-citation matrix. And one another matter that whether the paper is an authority paper, and how a paper can be authority, it is pointed to by many good hubs. So, and this is based on the coupling matrix. So I found it so intriguing and so interesting, despite that this is still is background, that people already have defined some kind of importance and ranking measures based on those co-citation metrics and the coupling matrices. And there are a lot of mathematical details that I will not go through here, but this is quite. I found it quite interesting. Now we are finished with the generalities. So at least I motivated a little bit why co-citation networks and why coupling networks are so interesting. But now I will speak a little bit about promising techniques that can help us in this project. So we spoke a lot about co-citation networks, and this is a measure of similarity. It's a nice measure, but what is the problem with citation network? Now I'm copying from the abstract of a paper that came in 2020. So at least this abstract, you don't need to read it. I can explain very quickly. What they are saying is that they say that the problem with citation networks that they do not take a holistic view of a graph. So you only look at your neighbors. You don't get the neighbors of your neighbors. And then there is a new technique that is very popular and getting becoming very popular in machine learning called deep graph neural networks that can, in a way, look at the graph not only from a local point of view, only neighbors, but from a holistic point of view. And what this deep graph neural networks will do, if you give it a graph, there are many approaches. What it will find an embedding. It's so-called n-dimensional embedding of the nodes in the graph. For example, in this case, we have the nodes, and then we what we do, we project them using this neural network techniques into two-dimensional space. And what does it mean? Nodes that at least are similar, have similar in the graph in some sort, will end up close each other in this two-dimensional space. So, and in this way, we can easily, I think, this is what I am expecting. If we apply those deep graph neural networks to citation networks or other type of networks that, for example, author networks, and we will be able to extract these similarity measures in a more powerful manner than doing some simple graph theoretical measures that are based on some handwritten mathematics. So because the operations here are more complex. There is also this so-called word embedding of word and word similarity. So it's also techniques from deep learning or neural networks, where for example we try to find similarity between words, but not based on classical semantic techniques. For example, how similar pizza is to pasta, how similar pizza is to Italy. And this is based again on embedding. So we take so there is a deep graph neural networks that take all the words and take a lot of massive amounts of text, and then based on how words co-occur together in the same sentence, we can find we can replace those words with coordinates into, for example, n-dimensional space. In this case, it's two-dimensional space, where, for example, what we can see is that words that are similar to each other will end up. So there are very nice properties, but one of them, let's say, is that words that are similar to each other will end up in close to each other in the n-dimensional space. For example, here, cat, kitten, pet, and they end up in close vicinity, close neighborhood. So those at least what I am trying to advocate here, that there are techniques for translating words into embeddings. Techniques, it means to translate words into coordinates, into n-dimensional space. And that will give us some kind of, that will help us to extract those similarity measures. There are also techniques that can take citation networks and then can project them also, so-called using embedding, into some n-dimensional space where we can see that nodes that are similar to each other, or papers that are similar to each other in the form of the network structure will end up close to each other. That can be of help, and that can be some features for our for a machine learning algorithm. So yes, I think there's the idea. Can we use those embedding features? So my guess is yes. And so, for example, citation network embedding, word embedding that I spoke about. So one of the ideas that the problem is here, the problem that we are also facing is that this is not really a supervised machine learning problem, because when we speak about supervised machine learning problem, we speak about annotating a lot of data. So you give me a lot of example of what you are looking for in order that the machine learning can create a classifier and helps you. But here the problem, we don't have that much capacity of labeling the data. So we start with some seed articles, and then the machine learning, these tools that we are proposing, maybe based on similarity, will try to extract some relevant articles. And here the idea, it might be that we can give some feedback to the user about, okay, these are the top 4 or 5 articles that we think are relevant based on some similarity measures. And then what is the idea that based on the feedback, because the user will give some feedback. He will choose maybe one that is most relevant. There should be a kind of way to train kind of our classifier based on those embedding to give better results in the future. So it will be kind of iterative refinement process where at each step the tool will extract some information, and hopefully the tool will, and then using some kind of guidance by the user, it will improve its performance over time. So that's yeah, that I think should be a way to go in this project. So, and hopefully the performance should improve, otherwise our approach will not be working. So what does it mean by the performance should improve? At least if in the beginning the tool gives, at least for the first 10, 4 or 5 articles, its accuracy is, let's say, is 50%. Hopefully it should go to, with a few iterations with the user, it should, this performance should improve. Yeah, so that was all from my side.
Thank you, Anis. I have one observation. I'm actually absolutely amazed at what different things people do classify as a simple algebra. What you think as a simple algebra is far advanced to what I think a simple algebra is. So I'm quite pleased. I don't really have to understand all those things. The other thing that strikes me with this tool, which I think it's very positive as well, is that iterative process that you are mentioning. Because being a scientist and working with things, I know actually how much a scientist actually needs to feel in control of the things, and that iterative process might actually give a scientist a little bit more sense of control of the process. And it might be actually easier to persuade the scientist actually to use that, because they still feel that they have some kind of input and control along the process. So that is very encouraging. So that was my observations and comments. I'm looking now for the hands up for the questions to Anis.
Well, I have a question. You don't see my hand, maybe?
Yes, I see it now.
Oh, I'm sorry.
Yes.
Yes. I just thank you for a nice presentation. Also, many interesting presentations today. I was wondering if it's possible. I have asked my team about it before, and I was wondering, have you thought about or playing with the idea of making, for example, fake abstracts, fake articles to learn to teach the machine? Because the problem is always that we don't have enough materials to feed. Could that be possible to do, you think? Or that is way too, yeah.
It is possible. I can answer, it is possible.
Oh,
it is possible.
So have you done it?
Yeah.
Have you done that?
There were some papers which do that, yeah.
Oh, that's very interesting.
Is it called? Is it? I'm not. Yeah, Radoslaw maybe knows about it. Is it some type of adversarial machine learning? Okay.
So it's a question to me, or?
Yes, it's to you.
Yeah, you see, because sometimes you have to start the iterative process from some article, from some document, and sometimes you create a dummy article, which, for example, contains your initial questions, just to start the whole process. Then if you have this, the first document, then you can compare the other documents to this document, for example.
Yes.
This is what I meant. But because I have a possibility, I think, to speak. Thank you, Anis, for a very nice presentation. And we also think about using graph and word embeddings. So I think we are going in the same direction.
That's good. So we can collaborate.
So this was comment, yeah.
I have just to comment, and I'm very grateful, Hong, to you mentioning a fake article, because that might be actually the way around in those scientific fields where you have few or non-structured studies. You could actually make, as Radoslav has mentioned, an article that actually contains your questions. So that might be actually the way around, and then you can feed it into the citation network. So that was really excellent thing. Thank you very much. Hong, your hand. Oh. Okay, your hand is removed now. Yes.
Yeah, but I would like to have a second question, if that's okay. It's not
Absolutely.
a question, but yeah, it's not that. I'm just wondering, like all the projects that you all have here, are there any librarians that are involved in the projects? Not that I'm saying that librarians are very important, but a lot of articles, how they are indexed, how they are, yeah, like just the whole thing around publications. I don't know, like, do you have librarians involved or not? And if not, why? If, yeah. That is to you, Anis, and also to you, Stein.
I think I can answer for the Norwegian part. That is why we have contact with your group, because we need some people who are librarians as well. And the other thing is probably Radoslav that can tell a little bit more about, because we were actually thinking of attending a conference of librarians last year,
right,
which was
right.
yeah. Well, don't be so happy about that, simply because the COVID has scuppered all the plans. Because the conference was supposed to be, what was that, September or October last year. So, but yes, we are going to do that, and Radoslav, I think you can cover that part better.
Probably not better, but we already spoke to librarians at my university, in the Institute of Jacek Postupolski. So we are in touch with librarians, yeah.
Thank
and
you.
we are still hoping that, because that conference is biannual, so we are still hoping that we might be able to present the project there. And hopefully, when we are finished, present the results as well.
Yeah, I agree with you. Yeah.
Is there any other questions to Anis or to anyone else that has presented before? Because now we are actually entering the part of the discussion. We have had quite a lot of discussion on the way. I will try and find the way as well of exporting the chat because there are some interesting links to articles and other information that can be useful for everyone. And as a part of the feedback after the meeting, I would like if the presenters outside my company, outside the Norwegian Scientific Committee, can send me a PDF of their presentation, and then I will share the presentations with everyone participating here.
Yes, we will send our presentation. Probably it's a good idea to put some, at least, presentation at our web page.
Yes, that was the general idea. So we could
okay.
So we can do that. The other thing I thought as well would be very interesting if you would agree is that we post the picture of the participants here. So Anis, if you can remove your presentation, and if everybody can get their cameras on, I would like to take a print screen.
Is my presentation removed now?
No, not yet.
No. Okay, so let me see how can I delete those. Stop presentation. Yeah, stop. Yeah, very good.
There. Excellent.
Yeah.
Can we have more cameras on, please? Okay, we have 3 more that are not interested in sharing.
Let me just get the back.
Yeah, you are on, Anis, so that's fine. Okay, I suppose they have. Right, I'll try and have a picture of that right now. Cheese.
I'm still out.
Yeah, that's fine. I've taken it now. So I was hoping that we could at least document this in this way. Right. Is there any more questions that we would have to any of the participants? If not, we are a little bit ahead of the time, but I can't imagine anybody would complain about that. With everybody being absolutely inundated with web conferences, I think we are getting a little bit fed up with screens all the time. If there is no questions, then I would like to thank everybody for participating. It has been really, really impressive what we have heard, at least to me, whose knowledge about this artificial intelligence is really minimal, and I'm quite looking forward to see the results and of course work with everybody. As the follow-up, as I said, I will send the presentations to everybody. I will send the information from the chat with the links to presentations, articles, and whatever of interest is in there. And the file is probably going to be huge, so I will send that at WeTransfer and email reminding you to check your spam boxes just in case it has ended up there, which it happens quite often. So thank you very much, and any questions, anything, just contact me and I'll try to point you out to the right person to answer. And once we get the presentation from Radoslav, you will have a link to the web page of the project, so you can go and have a look at more detailed information there, and as well contact to the people participating in the project. Thank you very much.
Thank you, Danica. I would like to thank you for very, very good organization of this web conference.
Oh, well, thank you very much, Radoslav. I think it's actually all people contributing here who actually has to get the credit. I was just putting some links to the teams. That's not a big problem. Thank you very much anyway.
Thank you very much. Thank you.
Thank you. Bye.
Thank you.
Bye.
Goodbye.
See you, everyone. Bye.
Bye.